Good morning, everyone. Third cup of coffee really did it. I'm Smruti Patel, VP of Engineering at Apollo. And for someone who's been building platforms and infrastructure for over 2 decades, I can't tell you how absolutely thrilled I am to be here, learning about all the awesome workloads and use cases that are getting on the graph. And yesterday, we saw so many great examples of leveraging the supergraph as this unifying API orchestration platform. We heard about API modernization that's happening at Ford Credit, to delivering rich, highly personalized and connected client experiences at CVS, to building APIs with a platform mindset from folks at Indeed, and just so much good stuff. And with that, today promises to be another action-packed day. We've got a range of topics from security and authorization from folks at American Airlines to delivering multi-party LLM-based chatbots from our friends at Netflix. And so with that, a very, very, very warm welcome to day 2 of GraphQL Summit. Woohoo! Here are a few of the many amazing talks from folks across the industry that we've got lined up on the schedule today. We've also put together a great lineup of technical talks from our folks at Apollo. And these are all lived experiences from practitioners and core operators from across the industry, folks who've dealt with not just technical challenges, but organizational challenges to get mission-critical workloads in production and at scale. And they're going to provide this useful lens no matter where you may be in your graph journeys. So please try fitting in as many as you can in your schedule. A big part of landing multi-year digital transformation journeys hinges on driving incremental value early and often for our teams, our users, our businesses. And we at Apollo have been thinking very, very deeply about what does it take to make this graph development experience, all the challenges Kenny talked about and many of our customers have faced. How do we make that graph development a whole lot easier for our developers and a whole lot delightful? And with that, I am extremely excited to go deep into one of our announcements from yesterday. That's Apollo Connectors, which we built to address this exact pain point and challenge that Kenny talked about. And with that, I'd love to hand it off to our tech lead who's led this initiative for us, our staff engineer, Lenny Burdette. Welcome to the stage, please, Lenny. Thank you.
All right, bear with me, make sure things didn't explode since 20 minutes ago. Yeah! Let's explode in a good way. Okay. All righty. I'm so excited to be here to talk about what we've been working on for a really long time now. We set out to make GraphQL easier, and it took a lot of hard work, a lot of trial and error, and a lot of conversations with many of you, so thank you so much for that. And I think we've cracked it. It's a new declarative programming model for GraphQL we call Apollo Connectors. And it's really fun to demo, so I'm going to jump right into it. We're going to build an e-commerce experience with listing and detail pages, and of course, all the client teams across all platforms want to use GraphQL, so we need something to handle operations like these. This is going to be a little similar to yesterday's demo that Watson gave. I'm going to do a few things differently so I can dive into some features, show off some different patterns, and also prove that I have 2 working hands, unlike Watson. So we'll switch that. I don't know if it'll help me, but we'll see. I also want to start with some real APIs. So here's an off-the-shelf CMS that has product data. I can fetch a list with pagination. The list comes back in this data property with a bunch of data and some metadata about pagination. But where I really want to start is the schema. Where I always want to start is the schema that meets my client's needs. And the first thing I'll do for connectors is add a new link. This both imports the directives and leaves the world of resolvers entirely behind. In fact, it even gives us immediate feedback that we have fields that are not connected to anything, something we'll need to fix before we move on. I'll define something that I can connect to declaring it in my schema with the source directive. I'll name it CMS, give it a base URL. And of course, I need to authenticate each request, so I'm going to pull an API key out of the router's configuration and add it to every request. Now I go about connecting everything. The language servers snippets come in really handy here, where I know exactly what I need to fill out, connect it to the CMS source. I'll make a GET request to that list endpoint, and I can use the field arguments as my query parameters. So I'll type those, and I immediately get an error that I typoed one. Your connectors and your schemas must be in agreement, and we will tell you when they're not. Then comes the most interesting part of the connector, which is the ability to map your API responses directly to your schema using a declarative syntax. This is where I'm going to make my first decision. I don't like data as a property here. It doesn't even indicate that it's a list. I'm going to choose to use items. That's what I put in my schema, and I can use this GraphQL-like syntax to just kind of alias it. I also need to got some metadata. Then I have ID, name, description. Image is still not connected, so I'll connect that as well. Hit save, and behind the scenes, I'm running rover dev, which watched this file, rebuilt my schema, restarted GraphOS router, which also died. And now I have access to Apollo Sandbox, so I can try this operation out. I'll just select all my fields. I'll select that limit argument as well. We got back some products, but we didn't get back all the data. This is really easy to debug, though, because of the new pane we added to Sandbox called Connectors Debugger, which lists all the requests that were made to fulfill this operation. And I did successfully make a 200 OK, but I have some mapping errors that shows me that that selection that I made isn't quite correct. I can tell exactly what wasn't correct there, that some properties weren't found. And that's because this very generic CMS happens to store everything under an attributes object, which is an implementation detail I don't want to carry into my schema. But this is really easy to fix. Just dig a little bit deeper. And now we're getting the data out of the attributes object instead of out of the data. And I can also have a few more that I have to do. And I'm also going to make one really specific decision, that the CMS uses an auto-incrementing primary key, auto-incrementing integer primary key, which is an implementation detail I also don't want to use it. The primary key in my data model for each product is a SKU. So I'll rename that as well, and that'll have some ramifications later. With those changes, everything rebuilds. I'll rerun it, no mapping errors. We get back our response. Within less than 5 minutes, we've written and debugged our first part of our schema. Thank you. Let's keep going, though. We add another connector, because we want to build a graph, not just a set of RPCs that happens to be in GraphQL. And the truth is, once you write one connector, each one gets easier. The patterns get really familiar. And so here's a way to satisfy that detail page, being able to fetch a product by ID. It also connects to the CMS. It maps the same attributes. But I have a hiccup, that this API doesn't happen to have an endpoint for fetching a product by SKU. The best I can do is reuse this same list endpoint and get back a list of products filtered to match certain attributes, meaning that my data will be an array while my schema wants a single object. But in addition to being able to rename and reorganize the fields using this syntax, we also have a set of declarative transforms. So I can transform that list into a single object without writing any imperative code. And that one should have been a lot faster. Again, that gets easier every time. I do need a ID to add as a variable here. 2 connectors, even faster. And it is too easy, so let's make it harder and let's pull in another data source. Let's say we use Stripe for all our billing needs, and we want to use its product catalog APIs to manage pricing and packaging. This retriever product endpoint represents products differently. We'll be able to handle that. And I really like this because now I don't have to worry about keeping 2 systems in sync. I can treat the systems as the sources of truth that they are. First thing I'll do is define the schema I want to implement. Again, always starting with what my clients need. Here's a bunch of fields that are not connected to anything. So let's define another data source that we can connect to. We can compose together any number of data sources in a single schema, creating a unified representation, even if your data model is spread across disparate services. But then where do I add this connector? Well, the endpoint I'm using fetches a product by ID. We have a field for fetching a product by ID. It already has a connector, though. But connect is a repeatable directive. We can add more than one to a field. Connect this to Stripe. Also a GET request, but if I was doing mutations, I could do a post or patch. Hit that Stripe endpoint and select all those fields, handling some snake case conversion, of course. This is going to give me an error. It's a little bit of a daunting error. Once you see a few of these, it starts to make more sense, but I don't expect you to read this. What it's saying is that our schema is not consistent. Currently, we can get to these price and dimension fields only when we go through this root field. If we went to the products through this list field, the first one we did, it's only connected to CMS. We couldn't get to those fields. That means there's queries our clients could make that just could not be satisfied, and we're not going to let you do that. So it errors, and we have to solve that. The solution, though, is very quick. I'm going to add entity true to this connector, which defines it as an entity connector, meaning it serves two purposes. It both implements this field, and anytime we have a reference to a product, its ID field, this connector can also be used to fetch this set of fields from that data source. Entities are the building blocks of your domain model, and with connectors, it's the building blocks of your implementation as well. While I'm here, I'm going to add entity true to the other connector because it can serve the same purpose, and that'll come in handy later. So our new fields showed up. That meant our schema did successfully build, and we got rid of that error. So we'll add them to that operation, run it. Two data sources in one API, all declaratively. It's really easy. We can see the two requests being made, but even cooler, we can see the query plan that the router generated, figuring out exactly what steps it needs to implement to fulfill this operation. And this is a great query plan. It fetches them in parallel really efficiently. And I was thinking, thank you. How would you have written this as a resolver? Doing the same thing of fetching from both endpoints in parallel is actually not a great idea, because if the client didn't want pricing and dimensions, you'd be making a request to Stripe for no reason. You'd just be wasting bandwidth. There are solutions for this, lazy fetching and look-aheads. But you know what's a lot cooler than learning those techniques and writing that code or trying to explain that on stage? Is just letting the query planner just figure the whole thing out for you. And we can prove that our schema is consistent by going to that original connector, the list connector, adding those same fields, rerunning that. We also get back our CMS and Stripe data in one request with a different query plan. And I didn't do anything special to make that happen. It just knew that it can go to the CMS first, get the list of products, then go to Stripe for all the rest of the data. And that's what I wanted to build here. That was the API that supports that use case for my listing and detail pages on all the clients. But now I need to get it in front of people. The first thing I would do is open a PR. And this is where the declarative nature of connectors really shines, because there's only one file in this PR. It's just the schema. A reviewer can see clearly and explicitly how each field relates to the endpoints, how the responses map to schema, and you should get a review really quickly. While we're here, we also want to run some tests. And GraphOS provides schema checks. So with running subgraph publish, or subgraph check, sorry, we're able to get a bunch of really important things tested. We make sure that the schema builds. We don't have any typos, any mismatches between our connectors and schema. We make sure we're not breaking any existing operations. And we make sure we're conforming to best practices. We have a couple issues here. Stripe uses lowercase for enum values, and in GraphQL it's conventional to use screaming snake case. And this is a really easy thing to fix from a schema perspective. That's all I had to do. But now our schema and our responses don't match. Do I have to write some code to deal with this? In fact, no. We have another really useful declarative transform here where we can say anytime we encounter the value on the left, let's replace it with the one on the right. This is great for enums, but there's a bunch of other really interesting use cases too. And we'd love to hear what other transforms like this would be useful for your APIs as well. So with that, we can prove that we have valid conventional uppercase enums, and our test would pass, or we've got it reviewed, we can merge, now it's time to deploy. With connectors though, publishing is deploying, there's no step 2. There's no coordinating the rollout of a service and the deployment, something I've talked to so many of you about. No more. You just run this command, GraphOS builds your schema, makes it available to any running routers, and within seconds, your clients have access to what we just wrote. Doesn't end there, of course. We want to make sure it's working correctly. We need to monitor it. And we've added even richer traces to show all the steps that the router took to satisfy this operation, including the individual connectors being called. So I can see that this connector for the CMS didn't error, is pretty fast, it's on the local network. Connector to Stripe a little bit slower, that totally makes sense because it's a third party. But this being GraphQL, we know what to do. Wrap that all in a defer. We now have improved time to interactive with absolutely no work on our part or our client team's part. And this query plan is just so cool. And this is just extending the promise of GraphQL here. When the declarative nature of GraphQL, when you write an operation, you're declaring, this is what I need, you figure out how to fetch it. And when you declare the relationship between your schema and endpoints, you're saying, this is how my systems work. And the query planner, its job is to figure out how to get it, which I think is really exciting. So with all that we did, let's talk about what I didn't do. I didn't talk about any languages, frameworks, code first versus schema first. Didn't have to think about what to name the freaking service. I didn't have to deploy it. I didn't have to write a single resolver. With connectors, we've reduced adoption and implementation of GraphQL to, I think, the bare minimum of steps in an organization where you actually care about code quality and stuff. Thank you. We think this is going to save you so much time and hopefully make the job more fun because you're not doing all that repetitive boilerplate stuff that no one wants to do anyway. And so, since I still have time, let's improve things with all the time I've saved and make the search of our new e-commerce experience better. Maybe our CMS doesn't do search very well, and we want to use a proper search appliance like Elasticsearch. So how would we do that? Maybe this is actually a case where connectors isn't a really good fit. Maybe what I'm used to doing is writing a function that uses an Elasticsearch client library and just kind of managing it in code. Fortunately, we can go back to that by just using subgraphs. I've actually been working in a supergraph the whole time. Here's my list of subgraphs. It's just the one. But we can add a second subgraph really easily, adding search, which I've implemented with Apollo Server, really boilerplate stuff, not interesting enough to show. And this is the schema that it implements. Adds a new root field for search, takes a query parameter, does the same pagination, keeps everything consistent. Note, though, that I am only dealing with the product's ID. That's all I had to do. I should be able to come over here. I have a new root field. I'll fetch everything that we've defined so far, add a search term. Yep, this is going to happen. Elasticsearch crashed. Hello, everybody. There we go. A nicely ranked list of products according to Elasticsearch ranking with CMS and Stripe data. Wow. I know. And hopefully that's the only time it crashes. This query plan gets really cool, right? It first went to the subgraph with GraphQL, got a list of product IDs, and then fanned out to my other two data sources, all declaratively on the latter side of that query plan. And when I see this, I just think about all the times I was writing web apps and having to like sequence a bunch of AJAX calls to do exactly this, and now it's done automatically for me, and done automatically for all my sibling teams on different platforms with query planning. And what this shows is that connectors works really great with the Patel Federation. But the secret is, the connectors are federation. What we did, well, we evaluated a lot of options when we thought about how to make GraphQL easier. And we've tried a bunch of different projects, open source tools. I've talked to many of you who have tried some of the automated API to GraphQL tools. And I know some of you have ripped them out later because they didn't scale or didn't make sense or just resulted in bad APIs. And so when we evaluated our options, we realized that only one of them made sense, which is to take the rock-solid foundations of Apollo Federation and extend it to understand nearly any API, not just GraphQL. Because Federation already had the attributes we wanted in the connectors product. It prioritizes demand-driven and abstracted schema design with a declarative system of directives. It supports a self-service collaboration model that scales as your teams and graphs grows. It statically analyzes your graph for consistency and correctness. It provides predictable and debuggable execution with query plans and the state-of-the-art query planner. And it all runs inside the enterprise-grade GraphOS router, giving you insane performance and efficient compute. So what we did is we took this, taught it about REST, added on that API mapping transforms, and now we have one cohesive system. You only have to learn federation. You only have to run the router, and you have access to all this power. I do want to touch on a couple of those points to really talk about the design. Your contract between your clients and your servers is so important and so expensive to get wrong. Putting the schema front and center makes it easier to collaborate on, makes it visible to more people. You're talking the same language, which is really nice. And hopefully it helps you find potential problems much earlier in the development cycle. And when you're working in subgraphs, which now with connectors are not separate services with all that overhead, just proper boundaries in your domain model, it makes it a lot easier to scale as your graph grows. And maybe the most important thing is that it preserves this critical aspect of your schema, which is that it is an abstraction layer over your underlying systems. If we were to derive your schema from REST APIs directly or from your database schemas or other sources, then you would lose the expressiveness and flexibility necessary to make the right trade-offs for that specific use case and all the other use cases that you haven't considered yet. It also would make it really difficult to make changes to those underlying systems, something I've done a lot, just swapping out a whole search appliance, for instance, without those changes then cascading into schema changes and potentially breaking clients. But a schema-first approach would not at all be possible, we think, unless you have really great tooling that makes the developer experience delightful. We're able to statically analyze this declarative system and give you feedback really early, as you type even, so you don't get surprised by errors in production. To be honest, writing something that takes directives and makes API calls is not the hard part. I bet some of you have even done it yourself. Where we spent most of our time and effort was in layers and layers of tooling, including the language server, which is just so freaking cool. And that is what we think will give you the confidence to run a system like this in production for many years. So, you will need APIs that work pretty well with connectors, but the requirements are relatively simple. For now, they need to speak JSON. All your services need to refer to entities through the same set of primary keys, so there can be agreement and consistency. You do need endpoints that serve as entity resolvers. And that actually points out something kind of interesting, because remember we use Elasticsearch for that search use case. It has a JSON API. We could probably use documents as entities. Did we need that whole subgraph? Could we remove it and just do everything with connectors? Let's give it a shot. Hey, it's still running, cool. I'm going to leave that subgraph alone, because if I removed it, we'd break our clients. I don't want to do that. But I'll come over here to the product schema, and what I want to do is define all products-related functionality in one place, regardless of data source. I'll add a new source for Elasticsearch. I'll define that exact same field only I don't have to repeat the other types because they're all in the same schema. And then I'll implement it with connectors, pulling out metadata and entity keys from the Elasticsearch API. This won't compose yet, though. I forgot that several times in demoing. Because that field exists in 2 subgraphs, we have to teach the query planner what to do about it. I'm going to choose to use the override directive from federation to effectively migrate live from resolvers to connectors. And you could use other federation directives here, like adding access control with authenticated and policy. I didn't have time to demo that, but I think that's pretty cool. We rerun it, no change. Exact same result. But our query plan shows it's all connectors. The whole thing is done in connectors, and it's probably faster because we removed a whole service and a network hop. So that's my demo. I'm really excited about this. To wrap up, just want to reiterate that we think Apollo Connectors is really a new declarative programming model for GraphQL that we built on top of the foundations of Federation and Router. And it provides this end-to-end developer experience that I think you're going to love using. It's been really fun to get not just federation errors, but like the connector errors as I'm typing. We did design it to extend to other data sources, and we'd love to hear from you where we should go next. But that's pretty much it. I mean, you can use connectors today, which is so exciting. Thank you so much to my team, dozens of people that made this possible. And so scan this QR code, you can get started either with an enterprise account or a free GraphOS trial account. This really became our favorite way to work with GraphQL. I hope you're already thinking about the schema you could implement in a few minutes, or the resolvers you could just completely rip out and replace with connectors. So that's it from me. Thank you so much for your attention. Thank you so much. Have a great time at the conference, and I look forward to talking to you. Have a great day.